All right. Today's notes is 10:9, which is the second to last section of chapter 10.
I think we should only have 2 days of these because we have like a movie day.
You think so?
Miss B, will you be here after school?
Yeah.
We're gonna look a party or something. I don't know.
All right. 10:9 is cosine and sine functions. Alright, so the first thing we have to do is we have to think again of our unit circle. And we have to put in our points for our every 90 degrees is what we're going to put in today. So this first one is what point?
Oh, gotcha.
1, 0. This point right here is
0, 1.
0, 1. Austin, what's this point right there?
-1, 0.
-1, 0. And this bottom one is, class?
0, -1.
0, -1. Now, I know that all of you know this, but it will help to talk about it. What degree is this when we first start? 0. Up here then is 90. And then class, what's this? 180. And this one is 270. And then back to it is 360. And the other thing we have to make sure we remember is that what is our x value? Cosine. So we have cosine of theta, and our y value is sine of theta. All right, example 1. Graph sine of theta. So we are going to graph sine theta on our x and y axes. So this is my y axis, and this is my x axis. We know that on our y's, what does sine go between? Sine goes between, and cosine, what's my lowest number that they go between? -1 and 1 is right. So on our y-axis, we know that we go to 1 and we go down to -1. Each one of these, hopefully you realized, was increments of what? All the way from, I'm talking the angles now. 90, right? So when you are doing on your x-axis, you do it in increments of your degrees. So we are going to go, our first point is going to be at 90. Our first point is actually going to be at 0. Second point will be at 90. Then we'll have a point at my 180. The next one will be at 270. And then the last point we will be drawing is at 360. All right. So now what we have to do is we have to think about what we have. We are graphing our sine theta. Sine theta was what numbers? Was it my x or my y's? My y's. So So when you go up here, what you're doing is you're looking at your y's for sign. So my first one, at 0, it's 0. So at 0, it's 0. At 90, sign is 1. At my 180, sign is 0. 270, -1. And then 360 is 0. Now, the one thing I want you guys to do is watch this. Your sign is a curve, so it rounds. I do not want it so you want to make sure you round it. And it does go on forever, and it keeps going with a wave. So you want to make sure it's a round. It's not like you don't have like a point. It doesn't come to a point, and it does continue on forever. If I needed to go graph the next one, it would continue to graph and go like this. If you ever need to see what your sign looks like, remember you can, let me get out of this just like, go to your y equals and go sine of x and then we have to go to our table set though. Our table, not table set, our window. Our window, we went from our x's, we might as well start at, well, we can start at -10, it doesn't matter. And we have to go to a max of the 360. And then our y's should be at -1, or actually you can go -2 to 2, just so you can see them. And if I wanted, so I could show you, what I'm actually going to do now is I'm going to, so 360 was my first phase, right? So it takes 360 degrees to get to my first phase. If I wanted to continue this, what would be my next, so I could see the whole thing? How would I find out what the next point where it would be ending? It would be double that, right? So if you had your 360 and you're timesing it by 2, I'm going to move it to 720 so you can just see the graph. So I'm going to go to my table, and I'm actually going to go from -720 to 720 so you can see a little bit more of it. So it's just going to, and remember this now is stretched in. It's the same graph, it's just now blown, you're looking at it. So it goes up and down just like that, just like a wave, and it's going to continue. That should make sense because the next one, when we get here, would be at 1, and then it goes down and around, and it keeps going. All right. So the things that we have to look at here is a couple of things. We have the domain. Let's talk about the domain of the function. First of all, what does the domain of a function mean? What values is that? The x. So what is the domain of this function? These arrows, what does this arrow indicate? It continues. And when if you look at it, if I were to stretch this and I said, instead of going to 720 to 720, I could go 1,000 to 1,000, 2,000 to 2,000. I could keep going, right? Negative to positive. It's going to keep going. So what would be my domain? All real numbers. Now range, what value are your range? Your y's, right? What's the highest number your y's get? 1. And your lowest number is? -1. So hopefully that makes sense. It's -1 is less than or equal to y, which is less than or equal to 1. And the thing that we have to talk about is a period. A period is how long it takes to finish one cycle. So yes, it continues on, but how long does it take from the start of it to the end of it to start it all over again? And this is 360 degrees. All right, we have here, as theta increases, from 0 to 90 degrees, sine of theta. All right, so what it's saying, and this is something that what you'll have to do with your stuff, is it says as theta increases. So remember, as theta increases, because this is really where your theta is. So as theta increases from 0 to 90, sine of theta, is it increasing or decreasing? Sine. Increasing. So it increases from what to what? So what did it start at? 0 to 1. Yep, 0 to 1. All right, so the next one, as theta increases from 90 to 180, sine theta, and I want you to think about what it is, from what to what. So you got three things. So you're looking at, as theta increases from 90 to 180, sine theta does what? Decreases from 1 to 0. Now, on your homework, when you do your homework tonight, I want you to try to draw your unit circle and try to recreate this graph without looking at your notes, and then go to your notes, because obviously I know you can copy from your notes to your homework. I know that you guys are all capable of that. It's the fact of, can you reproduce what we just did with using the unit circle? All right, so all signs are what you guys have until you get to FST. I'm pretty positive that it's been like 5 years, but I'm pretty positive they don't go any more complicated than having you graph sine of theta. There are different signs, but I don't believe they have you do any of that. So every time you graph right now sine of theta, this is what you're going to be graphing. So the biggest thing is, try to reproduce this graph in your homework without looking at your notes. Draw the unit circle and do it exactly how we did it. All right. With that said and done, I'm going to have you, I'm going to give you the unit circle back so you don't have to draw that right this second. And you are going to try, and I'm going to start you out, but you are going to try example 2. And you are graphing cosine of theta, is right. Remember that this again is your axes. So you have your y, and you have this one is your x-axis, which also now is our theta. And again, I'll help you set it up. You remember you're going in increments of 90. So you have your 0, 90, 180, 270, and then 360. I want you to see if you can figure out, and it goes from 1 to -1. I want you to see if you know where it starts. So come back up to your unit circle and see what cosine is, and see if you can figure out what way it goes. I'm going to give you a second to do that while I pass out your homework. All right, anybody need more time? All right, so starting at 0, what is my cosine value? 1 is right. So I have a point at 1. At 90, what is my cosine value? 0. At 180, my cosine value is?
Negative 1.
-1. At 270, it's 0. And then at 360
1.
is 1. Now, remember that these continue on. So if I were to graph more, it's going to go in a wave. So I want to go here. I want to show you. I'm going to go and I'm going to actually shut off my sign just for a second. And how you shut them off, if you ever want to know, you click on your equals. And let me put that up so you can see that. You click on your equals. Oh shoot, just a second. So you click on your equals and then you push your enter. That shuts it off. So now so see there's nothing there. So I'm going to go cosine on the second one. I'm going to go cosine of x. And I'm going to graph it. Now, remember that I have mine from 270, right? So what we graphed is the first period only. So we graph from here to there, but remember it continues on forever. So what does the cosine look like actually? It kind of looks like the sine one, except for it's shifted over. Because look at here. I'm going to turn the sine back on, and it's going to graph that one right there. So it's the same thing. It does the exact same thing, but it's just shifted. So just so you know, they're the same graph because it waves just like the other one. It's just when you graph from 0 to 360, it just has this. So, thinking about that, what is the domain of the cosine? What your x values, what can your x values be? What can my x values be on my domain? All real numbers is right. My range is my y values. Sean, what are my y values go from? So it goes to from -1 to 1. Yep. So my range is -1 is less than or equal to y, which is less than or equal to 1. I had to move it over, sorry. And then my period, again, is what does it take from the start to end the whole thing. It does continue around, but it takes just 360, and then it repeats itself. So it repeats itself every 360. So its period is 360.
So if it was like showing 720, it would still be 360.
It would still be 360. Yep, because period is just how long it takes from the beginning to complete the whole cycle. So and then it repeats itself every 360. So on this, on sine and cosine, as long as it's just sine of theta, cosine of theta, and I believe in Algebra 2 that's all you guys get, it's always 360. Now if they change it by adding a 2 here or a 2 in front, that's what changes it too. So, but I don't believe you guys have any of those. Okay? Alright, so each one of you should have this. Now, what I would do when you are doing this, because all of this really goes through and does the exact same thing as your notes, I would really try hard to recreate the graphs when you need to. Like on number 5, it says graph cosine of theta from 0 to 360. I really recommend you go through and try to do it on your own, and then look at your notes. Backside is more, well, actually the backside kind of gives you a little bit, bless you, a little bit of a different thing. It gives you a couple of graphs. So you have your cosine graph, but it increases, so it kind of just gives you what different graphs look like. Not this one's your cosine, and then it goes. These two are not. These are your. Does anybody remember what 16 is?
Yes, no.
16, your.
Oh, sorry. I was answering the question.
Oh, no, but what kind of graph that was? Your inverse square. Yep. All right. Take out yesterday's assignment. Number 1, you should have had 19.5, and then the other one is 60.5. 2, 23.6, and 156.4. 3 is 65.2 and 114.8. Questions on 1 through 3. All right. 4 and 5. You 4, you hopefully found 30, but I decided that let's practice and see what if there was a second one, so you can kind of see what the other angle would be. So we are still doing the sine. So what would be the other angle? How could I find that other angle of my triangle? 180 minus my 30 is right. So 180 minus 30 gives me how much? 150. Now, you always have to look back at the given angle. So see how this is the given angle? So, does 150 plus 22 add up to less than 180? Yes. So, since it adds up to less than 180, a second triangle could exist, or does exist. So, I'm going to actually leave that second one. So, what about this one? We have 85. What would be that second one? You have 85, so you have 180 minus 85 gives me 95. Does 95 and 45 add up to less than 180? Yes, so that means that triangle also exists. On 6, we had 22.5. What would be my other angle if it was 22.5? 180. We had 180 minus my 22.5 gives me 157.5. My angle that they gave me is 100. Since it's 100, and the other angle would have been 157.5. Do these two add up to less than 180? No. So that means that it does not exist. And why do you not see it? Oh, you just see it. All right. So it does not exist. So there only is one triangle. 7 is true because sine is positive in the first and second quadrant. 8 is false because at that point we have cosine is positive in the first but negative in the second. So you either have to change it to be cosine of 360 minus theta is equal to cosine of theta because it's positive in these two, or you could say cosine of 180 minus theta is equal to a negative cosine of theta because they're negative. And number 9 is 53. Questions on any of the front? Number 9? Sure can. All right, so the first thing that you have on number 9 is you have 120. So this would be 90, that'd be 180, so that's too much. So we have this degree right there is 127. So if this degree is 127, we always go down to our x-axis. So what angle is that right there? How could I find out what that is? So yep, so you go 180 minus 127, and that gives you 53. Now, the last thing you just have to make sure is sine theta is positive here. Is it positive here? And it's yes, it is. So since it's that, the answer is 53. All right, any others on the front? All right, back side. Back side, number 10, you should have 118 and 242. 11 is 211 and 329 degrees. 10 and 11, any questions? Yep. So the first step, and we'll do number 10 first. The first step is to take the positive of it. So you have to do cosine theta is equal to 0.47. So you always have to look at the positive. So how do I find theta? Inverse. So I'm going to take the cosine inverse of both sides. So in my calculator, I'm going to go cosine inverse of 0.47, and that gives me a theta of about 62 degrees. Then I have to think, where is cosine negative? Cosine, is that my x or my y? X. So that's my x, so that means it's here and here is where cosine is negative. So remember that theta that we found is here. This one is 180 minus theta. So I take how I got this one is I go 180 minus my 62, and that is your 118. And this one, do you remember what this quadrant is? It is 180 plus theta, and that is 242. So on 11, make sure you go sine theta is equal to your 0.513. Then you take your inverse. So theta will equal your 31, and then figure out what quadrants it's in, and then that's how you get it. Remember, this one is 180 plus theta, and this is 360 minus theta. Alright, when you have multiple triangles like 12 through 17, you kind of have to look at it and say, what am I given and what do I know? Well, since 12, 13, and 14 are right triangles, you know you have to use SOHCAHTOA. Alright, so I just use SOHCAHTOA. So 12 is 4.52, 13 is 9.5, 14 is my degree is 53 degrees. Then on 15, 16, and 17, I have to say, what am I given? What ones can I use? Well, 15, you have to use law of cosines. So I get x is 6. 16 comes down here to be 83 degrees. 17 is 7.6 degrees. And then 18 and 19 are your exact values, so you have to go back to the triangles. and 18 is 16, and 19 is 9 square roots of 2. Any of those you want to see? Yes, Doug.
Number 19.
Number 19. Okay. Anybody not done checking 12 through 17? I will. 16 is 83 degrees. And I will do any of them you want me to do. Alright, so number 19 says that we have a 45, 45, 90. So I have 45, 45, 90. And it says that my A is my 45. It says B is a 45. C is a 90. Then it says if side A, B, and C are across from the given angles, and B is 9, so that means this is 9, it wants you to find C exactly. So what it's doing is it comes and gives you your triangle, so 45, 45, 1, 1, square root of 2. So you're asking yourself, what did it multiply this by to get this triangle? So what did it multiply the original by to get 9? So 9, right? So because you're looking for your scale factor. So it's 9. So if this is 9, then you have to multiply everything to get these sides. You have to multiply everything by 9. So you're taking this by 9, so that's 9. So if it doesn't ask for this side, but what side would this be? 9. And this one is 9 square roots of 3, or 9 square roots of 2. Now, sometimes it's really easy to see like that. Not always is it easy to see, and that's why sometimes you have to set it up to say, what did they multiply 1 by to get 9? But you could see, obviously, that it's 9. So you're always looking for that scale factor. So number 18 is a little bit more tricky. Anybody not have? So the answer is 9 square roots of 2. Anybody not have this one? All right. So 18, just to really quickly do 18. 18 says it's a 30, 60, 90. It says that A is 30, B is 60, and C is my 90. And it says A is 8. So A is 8, and find C. So again, well, this one again is an easy one. So we have here, this one is 1, this is square root of 3, this one is 2. So again, this one you can definitely just see it. What did they multiply this by to get that? So what did they multiply 1 by to get 8? 8. So you would multiply this by 8 to get it. So the ones that are hard is when they multiplied something to the square root, then you have to divide it out to find out your factor. So this again is 8. So you must multiply everything by 8. So this side is 8 square roots of 3. This side is 8 times 2, so it would be 16. So you always start with this, and you're trying to blow it up to that degrees, right? Any others on the back side, front side? Any questions? All right, that's a wrap then.